The enzyme RNase A require the formation of 4 disulfide bond. Among us, it 8 cysteine. If this is entirely a random phenomenon, the probability that the first correct disulfide bond will be formed is 1 by 7. What is the probability of the other 4 correct disulfide bonds? So what is disulfide bond? Disulfide bond basically is the bond with SS bond which is present in with the cysteine, methionine amino acids. So here they have asked about the probability and they have mentioned that 1 by 7 is the probability of the first correct disulfide bond formed. So the one of the remaining 6 cysteine residues then randomly reform its proper disulfide bond is 1 by 5. The overall probability of the RNase A reforming is 4. Its 4 native disulfide length would be how much? 1 by 7 into 1 by 5 into 1 by 3 into 1 equal to 1 by 0.5. Or we can say 105 base is the 4 correct disulfide bond will be there. Next question, a protein has a molecular mass of 300 kDa. Okay. When measured by the gel filtration, when subjected to gel electrophoresis in the presence of STS, the protein gives 3 bands with molecular mass of 300 kDa protein was there. Alright. And in the presence of STS, it broke down into 150 kDa, 100 kDa, and 50 kDa. When electrophoresis is carried out in the presence of STS and D3-tol, STS plus DTT. Here, question can also include instead of DTT, beta mercaptolithanol, which has the property to break disulfide bonds. STS has the property to break all the bonds which is present in the protein and to give the negative charge to the protein. In the presence of both STS and DTT, 3 bands again formed molecular mass of 100 kDa, 75 kDa, and 50 kDa. So as you can see here, the 75 kDa is the double of what? 75 plus 75 is the double of 150 because here 150 is not given in this. This 150 is not given. Maybe the possibility that it could have been broken down, right? So 75 plus 75 would be 150. So that's the answer of this question. That is 150 fragments into 2 pieces. Therefore, there appears to be 4 subunits to this protein and 75 kDa bonded to each other by disulfide bond. Next question is why polylysine assumes different secondary structure conformation at acidic alkaline condition. So the answer of this question is due to the high charge on the lysine chain. Lysine chain is made up of KK. So this is a polylysine due to the high charge, acidic in nature. Sorry, lysine is basic in nature. So definitely it will contain the positive charge, and if polylysine chain is present, then highly positive charge. So at a high pH condition, that is we can say 10.6 as written in the papers, PLL polylysine transform into alpha helix conformation. Alpha helix conformation. Because the charge on the PLL is reduced at a pH above the pKa of the lysine side chain. If pH would be higher than pKa, then what would happen? Basic condition would be there, and CO double line negative would be charged highly. If pH would be less than pK, then acidic condition would be there, and H plus ion would be in higher amount. So likewise, the concept follows here. You can see alpha helix conformation was made when it is subjected to 10.6 pH. At low pH, what happened? The lysine wouldn't be charged enough, therefore P2 means amide 2 reason. And beta structures at high temperature form. These form at high temperature, and the other possibilities I told you through mouth are included in this question. This is all about today. Thank you.